right, this is the foldable for section 9.1, and what we're gonna do is cut it in half at the dotted line. And then what you're gonna do is put this one that says Understanding Quadratics on top, and you're gonna find the number 1, and that's gonna go right underneath it. You make it line up towards the words. Once you have it set up that way, you're gonna fold it back at the understanding right here like this, so that you can get the numbers 1, 2, and 3 on the foldable. Once you have it folded, please staple it together. If you don't mind, please help a friend. Make sure that they're okay. Like I mentioned, this is the foldable for section 9.1. And what we're looking at is quadratics. What quadratics mean is still an equation where you have x squared. Here we're looking at equations, so usually we look at y is equal to x squared. Let me tell you some things that are not okay. If it has a higher power, like cubed, this is no longer a quadratic. If you have an exponent lower than a squared, so for example like this is not a quadratic. This is actually a line, a linear function, and we've talked about those at the beginning of the school year. So it has to have an x squared. But we've seen all kinds of quadratics already. So 9x squared plus 36x plus 36 is an example of a quadratic that we have already seen before. So I'm going to say it again. What is important is that it says x squared. Let's take a look inside. We're going to plot the points 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, 1, 4, 1. And what this picture looks like, it looks like a U-shaped. And this is called a parabola. This U-shaped thing is called a parabola. What I want you to know about a parabola is that it does keep going on forever because the table of values keep going forever, like a line. And it does spread out. The further you go, the further out the parabola will actually get wider. All right, let's graph the next one. Negative 5, negative 2. 4, 1. Negative 3, 2. 2, 1. Negative 2, 1. And negative 1, negative 2. Again, it's not a V shape. It's a U shape type of graph. And I'm going to state it again that this does keep going further and further apart, and it'll go down forever. So we can have an upward facing or a downward facing parabola. So anytime you were looking at the picture, it's called a parabola. The equation for these are still called quadratics, but its picture is called parabola. All right, let's keep going. It says the parabolas are symmetrical about the central line called the axis of symmetry. So what is it saying? It's saying that it's going to look the same on a particular line. If you fold it in half, it would look the same. The axis of symmetry cuts the parabola in half vertically through the equation of the form x is equal to some number. What is that number? That number is the x value that crosses the parabola. So for example, on this one, this ordered pair right here would be 0, 2. And we're looking at just the x value. So x equals 0 makes this line. It's easier to tell when it's not on the y-axis. That if you would fold at that line, they would be the same. And this one is negative 2. The x value is negative 2. Then over here is the line where it would cross. This one crosses the x-axis at 1, 2, 3 at a positive 3. That means that at the positive 3, if I would fold this thing over, they would look the same on both sides. And that is the axis of symmetry. And then the last little part for today. It says the axis of symmetry intersects the parabola at only one point called the vertex. Maximum. So if it's facing down, remember, and it's a U-shaped looking thing, here's its maximum or highest point. If it's an upward facing, up facing, smiley face looking deal, the minimum is its lowest point. The vertex is where the range of the values begin, listed as y is greater than or equal to, or y is less than or equal to. So let me explain that part. We first need to find the vertex. The vertex is that point where it's a maximum or a minimum. This one is 0, 2. And then the domain are x values. Don't forget that this thing keeps going on forever up and it separates. That means that we could have any x value from the left to the right, and this keeps going up and it gets separated. That means the domain is all real numbers. That means it covers any x value. The range, though, is the y values. Y values. And the y values start at the 2. That means or equal to. And this looks like they go greater and greater and greater. So the y is greater than or equal to 2. We need to start at the vertex. This vertex is negative 2, 0. The domain will still be all real numbers because these keep going on forever and ever and stretch out. But the range now starts at this 0 on the y values. Remember, range is y values. So y starts, that means it has to be equal to. And then these values are less than 0. And that's what it means, that the range will always be greater or less than, depending whether it's a maximum or a minimum.